for London.AI 22. It's a bit weird to think that it's been 5-6 years of us doing this, but super excited to be hosting another edition. For obvious reasons, we're doing these on online now, but we can't wait to have a face-to-face event when we can. So if this is your first time, we're a community of AI practitioners from tech companies, startups, academia, and in Nathan, in my case, on the investment side. I think what makes London.AI quite cool is not only our amazing speakers, which we'll get a chance to present in a second, but also the community. These are some of the companies and organizations that have signed up for today's event. So I think normally so something about the speakers real quick. We have Flowrite, Monzo, and Humanloop with Aaro, Neal, and Raza. We're pretty excited about having an NLP focused meetup. We try to have a theme, and that was the theme of the evening. At the intermission, Nathan will tell you a little bit more about how you can donate some funds towards the RAAIS Foundation and what those go towards, but I'll let him chat about that in a second. And one thing we're particularly excited about for today's meetup is half the fun of London.AI is being able to catch up with the community for beer and pizza after, and just chatting away with some of the cool companies we mentioned before. There's always companies looking to hire, academics looking for jobs, startups looking to engage with corporates. And we've worked with the team at Cosmos. Cosmos is an online meeting and events, virtual events company. The UI around it is really cool. It looks like 32-bit art, similar to Legend of Zelda or Pokemon on Game Boy. And we thought that kind of tied into the DNA. We don't want to spoil it too much, but what it means is basically after this is over, after the talks are over, we'll post the link below and anyone will be able to just go. I don't want to spoil it because half the fun is discovering how the UI works, but you'll be able to meet up with the speakers and ask them questions. Each one will have their own room. So it's kind of an interesting way of organizing this. And lastly, if you enjoyed this and you want to keep coming to events, we highly recommend you register on whatever your favorite platform is. Newsletter, we ping you only about the event when it's about to start. Same for Facebook and Twitter, and we're also on Clubhouse now. But without further ado, let's get the event going. Nathan, do you want to introduce the first speaker of the evening?
Yeah, sure. So first speaker, we have Aaro, who's dialing in from Helsinki in Finland. His company is kind of at the forefront of using NLP and GPT-3 for productivity reasons. He's got a pretty cool product that I'm really excited to see the latest of. So with that, welcome to you, Aaro. Feel free to take it away.
Thank you, Nathan. And thanks, Alex, for inviting me. Super happy for the opportunity to tell you more about Flowrite and what we're developing. This probably won't be the most technical talk you're going to hear today, but I figured that would be perhaps interesting for some of you in the audience to hear our journey of building a product on top of language models, and in our case, GPT-3, and obviously like how we got access to it initially and what are the different ways of using it. I'd also love to give you a quick sneak peek of our current product, which actually not many people have seen yet. So a quick demo will be coming. And maybe to start up with a bit of a background. So I'm based in Helsinki. I've been part of the startup ecosystem here for multiple years. So I spent a while organizing this startup event called Slush, which some of you may know. And through that, ended up as the CEO of a startup accelerator named QS, which is kind of the #1 program here locally. And that was a great and helpful experience. Now looking back, I was able to oversaw roughly 100 companies in their earliest stages. So quite a nice experience to have before founding your own first company. But anyways, like my work at QS kind of fostered the idea for Flowrite. As a manager and executive and entrepreneur, I was spending just like countless of hours every day writing different things. So emails, writing cold emails, replies, communicating with different stakeholders, my colleagues, and kind of as a CEO of a small company, I was also doing a lot of content work and writing social media posts, whatever. Like writing was just a huge part of my daily work. And as a big fan of productivity tools, I was like obviously using Grammarly and other writing tools, and I really loved many of them, but felt that like compared to how much time I actually spent on writing, these tools have at the end kind of minor effect on my productivity. So if you think about like fixing your grammar with Grammarly or using Gmail's autocomplete feature, whatever, it's kind of minor productivity gains at the end of the day. What hasn't yet existed before the rise of these language models have been kind of generative writing tools for like everyday use and mass market. And our thinking was that if we can help people be more productive in their everyday writing, even in some like very small way, it can be a really, really exciting value proposition for a lot of people. I like to contrast this with, for example, calendar or task management apps that we're also I'm also using and we're also using. Think about like how many of those there are out there compared to like how little time you actually spend on things like scheduling or task management. It's very little. On the other hand, like how much time many of us actually spent on typing on our keyboards. So the problem was just so apparent to us, like no question about it. But it wasn't until last year when me and my co-founder came across GPT-3 and also like earlier GPT-2, but GPT-3 during the summer when they announced it, we just instantly knew that like this is how it could be done. The idea that we had, actually share my screen so you can take a look at the website. The idea we had was to build kind of a horizontal writing tool, a browser extension that would integrate to wherever you're writing on a daily basis, in quite a similar fashion to Grammarly, for example. And the idea was, and still is, that by developing our own technology on top of the generative functionality of GPT-3, we'd be able to model a user-specific style and a tone of voice in different situations. So it wouldn't be just kind of a GPT-3 wrapper, although that's what many people think. But there's actually quite a bit of stuff happening in the background. So we got really excited about it. My co-founder and I both just dropped our previous commitments and started working full-time instantly. First thing that we needed, obviously, was the access to the API. And then like when we applied, it wasn't that easy to get access. There were only a few hundred people in the beta. Now it's like tens of thousands of people in their Slack, at least. So we ended up hustling quite a bit. We managed to get it in 5 days. If you're looking for access, you might want to check this blog post. But that felt like a huge achievement back then because the API was just so exclusive in the early days. But we started building immediately. Back then, there wasn't much documentation about like how to structure your prompts and like with what kinds of like samples should you have to generate the best responses. Nowadays, the documentation is really like super comprehensive. So once you get access, it's like easy to get started with GPT-3. What they provide you with is this playground. If you've gotten to the API, you probably know this. But you can test like different types of prompts in a very similar manner to how you'd be making those API calls. So this is kind of the string part of the prompt, and these are all the numeric parameters that you can adjust. For example, like temperature, which indicates the randomness of the text, and a few other settings as well. And the common notion back then was that you would give GPT-3 a set of examples, and then it's able to continue that sample set according to your input. So if you wanted to build a chatbot, for example, your prompt would include a few question and answer patterns. So you'd either have kind of a static sample set that you sent on every API call, regardless of the use case, or you would have like dynamically populating your sample set from for example, your own database of loads of samples by looking at the context of the user and then trying to find the best samples for that use case. And then at the end, you'll be able to ask it a question and it's able to answer according to the sample set. And this is like how the API call then would look like. So it's extremely simple. And like this kind of a prompt design was the strategy that we used for our first demo. This is, yeah, I just take a quick look at it. The first thing that we built was like, it's really easy to get started with GPT-3. We made this in like 3 or so weeks. It's really easy to get started. This was kind of a simple web-based sandbox version of it. Our aim with this one was mainly to get kind of an internal validation and figure out whether we can actually achieve what we wanted while still keeping the API costs at a moderate level. So here you can see kind of a simple example of generating an email based on those instructions. And the result that we had from that, like internal research was that yes, we can do it. And at that point, we felt quite confident about announcing the project. So we released the demo, we published the website, we did the first announcement, and won't go into too details, but we ended up raising a funding round from Seed Camp and Lifeline Ventures and a few angels. And like fast forward to today, we've been very focused on getting our beta product finalized, and we've recently started shipping to our first users as well. The product is like much more comprehensive nowadays. You're able to use it in both our web app as well as on your browser. So for example, Gmail, you have this Flowrite button appearing in your Compose window. And here's kind of like a simple example of booking an onboarding call. And the experience is built around templates. So you're kind of able to build your own templates of your most common use cases. Yeah, we're shipping features almost every day. There are currently about 10,000 people waiting to use the product, and we just have no way of efficiently onboarding them right now. So quite exciting times, and we're definitely hiring as well. I figured that I could maybe wrap up the talk with some thoughts on GPT-3 powered products in general and how you should maybe think about using the model yourself. As I mentioned, I'm not particularly technical, but can talk through our use of GPT-3 on a more general level. We've spent like countless of hours playing around with the API, and we know that especially in a use case like this, it's really easy to get started, but in order to get to like really high accuracy, you need to have your own layer of AI or logic or whatever you want to have on top of GPT-3 that optimizes your prompts for every specific situation. And that's obviously slightly more difficult than just building a cool looking wrapper around the API. There's so many GPT-3 tools out there nowadays, and we've tested many of them, and feel that only a handful of products we've seen have been able to go beyond that, like GPT-3 gibberish generator level, and actually build a product that is stellar in terms of both like accuracy and user experience. And we know that if you want to really build like a remarkable company that stands the test of time, we need to have those two things in place, especially as we're building on external technology. Maybe regarding GPT-3, a couple of words about that as well. OpenAI has lately released new engines within GPT-3 other than the original 4 ones. So the model that was mostly used, and I think it's still mostly used, is the DaVinci. They've recently announced Instruct series. So instead of providing GPT-3 with kind of like illustrative examples, you're able to use kind of like descriptive language. So you can, for example, say, explain the moon landing to a 6-year-old in a few sentences, and DaVinci would output this. So it would kind of repeat that loop, and the instruct series would kind of like answer the question directly. So this gave like a lot of new possibilities for us and many others as well. And another thing that seems to be getting more popular is to use certain models of GPT-3 to actually like generate prompts that you send like then to another model. We've also explored this quite a bit, and it's working quite well for certain things. And what we're like also constantly working on is the thing that I mentioned earlier, which is to kind of understand the user's behavior in certain contexts as well as possible. So for example, looking at the edits that they're making to the generated texts and making sure that the prompts get better over time across all users, but also for each user individually. So that's about it. Maybe as a final word, I think it's going to be extremely interesting to see how the language model landscape evolves. So far, I think we've only seen the surface with plenty of exciting tools built with GPT-3, but who knows which kind of models there are available from OpenAI or some other players a couple of years down the line. So that's it. Something that would be maybe interesting to check is that we've been posting bi-weekly product updates since our very first launch. So if you want to take a closer look at what we've been building, you can head over to flowrite.com/updates and join the waitlist, and you're able to earn these cool notebooks by referring your friends. All right, thanks.
Great. Thanks a lot, Aaro, for that. I think in terms of questions, if you have a question and you're on the Facebook Live, then just ping away your question as a comment, and Nathan and I will select a few. We will keep the number of questions quite limited this time, just because we want to head over to Cosmos after, which should be fun. I guess the question which we're seeing in the comment section, and which I have myself, Aaro, is what's the wait list looking like? And if someone signs up, and how much time will we be able to test it out? Just full disclosure, even having invited Aaro to London.AI, I still don't have access to the wait list. That's not my passive aggressive way of asking for it, but it just kind of goes to show a lot of people are signing up. So yeah. I'd be curious to understand that.
Yeah, so we're currently having a few dozen people in our beta. That feels kind of a good amount of people from which to kind of actively collect feedback from. But we're like inviting more people on a weekly basis. I think we're gonna really scale up the invite list in a couple months, or already probably during March.
And we have a question from Raza, who's one of the speakers, just asking if you have any concerns around building on top of an API that you don't fully control. Yeah,
for sure. I think like that's also the most asked question when we be talking with investors. So it's definitely something that we're thinking about. And currently, it's very true that we're quite dependent on GPT-3. We haven't like really explored other models for this use case in particular. We also believe that once the language model landscape evolves and there's going to be many other players, then also the risk associated with being too dependent on just one player diminishes.
Got it. And we have a few other questions from recurring London.AI guests like Claude-Éric Mars and a few others, but they all relate to actually, will you be using GPT-3 indefinitely? Are you working on your own proprietary stack? So I think wrapping up with that might make sense.
Yeah, so like currently we're not building kind of a language model ourselves. So we're basically building just like logic and our own AI on top of GPT-3. So to be honest, we don't have a plan in terms of that yet, but who knows, like a few years down the line, and if the company really scales, that might become relevant to us.
Cool. Well, Aaro, thanks a lot for a really interesting chat. I think this is one of the few GPT-3 tutorials and explanations we've gotten. And if anyone wants to learn more about this, then just stick around. And once we go into Cosmos, you can ask more detailed questions to Aaro. Nathan, do you want to introduce our next speaker?
Yeah, so next up, very excited to have our friend Neal come and present about his work on NLP and other things at Monzo, where he's currently a director of machine learning. He's there by way of Skyscanner previously and UCL before that. Of interest, he's been writing quite a lot of kind of at the forefront articles about putting machine learning into production and building useful products on his Substack, which I think is Operator AI, right, Neal? And also on his personal website. So it's quite a cool way to get a sense of some of the things that he's grappling with every day and playing guitar to calm himself down in the evenings. So over to you, Neal. Thanks.
Cool. Thank you for having me. I'm going to share my screen. And give me a shout if you can't see the slides. Oh, I'm all the way at the back, I think. Yeah. No, that's all right. Cool. So I'm Neal. I work at Monzo, and in case you are not from the UK or not aware, Monzo is an app-only bank that was founded about 6 years ago now. We've just crossed the 5 million customer mark. And I've been at Monzo for about 3 years now. And as a bank, there are a million different machine learning problems that we can tackle across credit risk, across financial crime detection. Being an app-only bank means that there's a lot of things that we can build into the app that can use machine learning. But where NLP comes into play the most is with our customer support. So where are we using NLP today? If you open the Monzo app and go to the help screen and start searching, you're going to be interacting with a BERT encoder, which is powering our search for help article search results. Back in 2019, we ran a few experiments with actually giving customers automated self-service directed answers for a series of queries. And after running a number of experiments there, we pivoted away from this approach, but those were a bunch of language models as well. What we're using now is a number of different text classifiers to figure out who the best person is who can help you based on your query. And so that's an internal system that we call direct routing that combines rules and NLP to make a decision about who the best agent is to help you get to your resolution quickly. Once those agents get your conversation, they receive recommendations on how to reply to you. And the typical business problem that we're trying to solve here is that we have a bunch of different canned responses that are stored in a database, and we want to guide the agent towards what is the right response that they should give you, so they don't have to type out all of the instructions on how to order a replacement card in the app. But we leave it to the agent to actually diagnose and pick the right response for you. And then finally, we run a bunch of language models that are just analyzing the conversations, and we use these for different forms of analysis and insight. So the example that I have here is just a very simple one of detecting the end of conversations and allowing us to have metrics around how long are conversations, by factoring in whether conversations appear to be a little bit longer because our agents are just being nice humans to our customers. So how do we enable all of this to happen? This is the topic that Nathan mentioned that has been on the forefront of my mind, primarily because as we see with language models since 2018, training the model has become more of the trivial part of the problem, or indeed as we heard from the previous speaker, these are the sort of things that are now even being offered by APIs. The harder part of the problem is the everything else. So I think in the future for data scientists like myself who are working in companies, the real challenge is going to be to take what exists and to tune it for what the business needs, and then to make it actually happen. More so than the problems that we would have had a few years ago of figuring out what the business needs and then even seeing whether training a model in that domain is even possible. So for the rest of my time today, I thought I'd give a quick whirlwind tour of the rest of the OWL and all of the bits that we've had to think about and build while we've been shipping a ton of models into production. So it boils down to these 6 things: a feature store, a way to create labeled data sets, a model store, serving infrastructure, monitoring, and data labeling. A lot of these different pieces of the puzzle you may have encountered before, but I'm just going to give you a run through of what each one is and how we use it and why we built it. So let's start with the first one. Here's a screenshot I took from our staging environment. And you can see one of our engineers was running a test in our chat screen and was just bashing the keyboard over and over. But it's not too far from reality in that the messages that we get from customers can be very disjointed. They can hit enter whenever they want. And not only that, they can also sometimes interact with buttons in the chat screen, which then appear as text, but they were actually clicking buttons, not writing words. So what is the key problem here is that now we have all of the data that we get from customers sending messages and receiving messages and tapping buttons, and maybe in our historical data interacting with a bot. But we need a good way to be able to take all this data and feed it into machine learning models. So the way that this data is traditionally represented is in terms of the individual messages that are sent and received. But the way that we want to feed it into the models is a bit more akin to that earlier screenshot where I'm talking about conversation turns. So all of the text that the customer wrote, and then all of the text that we wrote back, and so on and so forth. So what we do with our conversation feature store is we eat up all of the messages that are being sent and received and do all the pre-processing on them so that we can easily generate the content that we want to feed into a classifier. The main reason why we have this, or what makes it useful, is it's the type of thing that we would otherwise be solving over and over again every time we wanted to ship one of these classifiers. So it's a kind of solve it once and then apply it many, many times situation. The second benefit from this is that every time that our conversation feature store figures out all the turns in a conversation, then it will fire hose loads of data about that, and we can have that for training future models. So the second thing is onto what I just mentioned. We have now fire hosed all these different conversation turns, but how are we actually going to use these to train models? This is the usual classic data science task of let's generate a label data set. And I've seen probably way too many projects start from the raw data and take it all the way to creating label data, and then only then starting to train models. And a key risk that I've seen in these projects is you end up with a million pipelines that are all kind of doing similar work. And you end up with a lot of people rediscovering the same bugs that you have in the data over time. So we treat creating labeled data sets as a type of product that you build. And what we have done is we have two pipelines that we aim to use to create all of our data sets for training language models. The reason I say two is because the two shapes of problems that we take where we train models are generally look like this. One of them being training classifiers on the first turn or the second turn or the final turn from the customer. And then the labels could be things like, what was the conversation tagged as? Was it an urgent conversation? And so forth. And the second flavor that we take is more of this question answer pairs that we use to train our encoders. And we obviously need to be able to create these different data sets for different purposes, but the outcome is always the same. So the way that I think about it is that when a new data scientist joins my team, he or she should not have to start looking from the raw data again in order to create a nice, clean labeled data set to train a model with. So there we go. That's the second step. We've now trained a model, and that's the easy bit. We use Hugging Face, and this is the next bit, which is we train a model. So what do we do with it? And September last year, I asked this question on Twitter. I did write it up. It's on. If you Google my name, you'll find it on my personal blog post. But one of the things that prompted me to tweet about this was the fact that we had recently stopped the very painful process of getting all these models into production manually. And I wanted to hear how other companies were doing it. And it turns out that this is a very manual step that a lot of companies are taking of, yeah, I would put the model artifact into an S3 bucket and then tell an engineer where it is, and then he or she would do the rest of the work, or similar things. So what we have instead is a model store, whereby when you finish training a model, the last thing you do is upload it to the model store. And usually we will we'll be uploading the one that we want to ship into production. So we're not treating this as just a dumping ground of models. We will have done the science bit of the work ahead of that. What this model store does is it versions all of our models. You give it a domain. Every time you upload stuff into the model store, we are getting data about what's happening. What models are we training? How many do we have in production? What state are they in? Are they in shadow mode deployments or not? And that's a lovely dashboard that I like to revisit from time to time to see whether there's certain areas that we haven't been paying attention to. But most critically, we use that same model store to power all of the microservices that are serving predictions from these models. So as these microservices are being spun up, they're also going to be querying the model store to say, give me the latest. In this screenshot, I have a golden ticket classifier. Golden tickets don't even exist on in the Monzo app anymore, so we've thrown that model out. But it's a good example. So now we have a way to collect data, munge it into features, turn it into labeled data sets, train models, put models into model stores. What about the actual serving? So this is an area where I'll just point you to this QCon talk from a couple of our staff engineers, because it's an hour and it goes into an incredible amount of detail about our backend infrastructure. But as you can see from this tweet from Suhail, Monzo is more than 1,500 microservices. Most of them are written in Go, which I hear is Nathan's favorite programming language. And but we need to somehow fit Python and BERT encoders into the mix. So what did we do? I talked about this at another Data Talks Club podcast recently, but effectively what we do is we write Go services that whose job is to orchestrate all of the classifiers that we have that are in production. So let's take a simple case of having different BERT encoders that are classifying whether a customer is talking about a certain topic, where those A, B, C, and D could be forgotten their PIN, lost their card, needs a bank statement, and does Monzo work abroad? Every time someone in my team trains one of these classifiers, all they need to do to get it to actually be connected up to the rest of the production system is to connect it to this Go orchestrator. So this makes the journey much faster for the folks in my team, but critically, it also allows us to write business logic around our classifiers. And so a very simple example of that is that if we have a classifier that is trying to detect whether a customer has lost their card, we did find, rather than lost their card, that they want to order a replacement card. We did find that looking at the data and trying to tweak models to really differentiate between needing a replacement card versus their replacement card hasn't arrived quite yet was proving to be a very down in the weeds problem, and one that we could much more easily solve by writing a rule of like, have we sent a card to this customer in the last 7 days, rather than trying to tease out the differences in the language data itself. The final benefit of this kind of structure is we can also plug in models without turning them on live, and we can test them out for a few weeks in this shadow mode deployment, which has been an incredibly useful tool for us over the last couple of years. So the last 2 bits, monitoring and analysis. I know that there are several tools out there that are cropping up for machine learning monitoring. The approach that we take is to monitor our machine learning models in the same place that we track our product performance. And so at Monzo, all of the data goes from our AWS production stack into GCP and BigQuery, where we run all of our analytics. And then all of that gets surfaced into Looker, where we build dashboards. So in this case, I felt it would be really boring to just show a screenshot with like precision recall types of numbers. And so I found a Sankey chart that Ellie in my team made. And here she was looking at what customers were searching for in the app, what help article they were landing on, and then if they got in touch with customer support, how those customer support agents were tagging those conversations. And it was an analysis that was looking at 3 different models. So our search model, all the way to our topic classification model. And in the bottom right, I have just some basic tracking where we're looking at what sort of decisions in terms of topics is our system making over time. And we use this to spot anomalies and see whether everything is as we expect it to be. The critical part about putting these things in the same place as where we track product performance is that then we can shorten the feedback loop with product squads. We can show them that, oh, customers are always searching for this, and our model doesn't do so well at surfacing the right answers. So we're going to work on that part of the problem, but maybe the root of the problem is that this needs to be made more discoverable outside of search, and customers shouldn't be searching for this in the first place. So it helps us to drive those types of conversations. And then the last one is one of my favorite ones. All of the examples that I've given so far rely on us having labels. And for many different things, we do have them. So I mentioned that our agents will tag conversations while they converse with customers. And then there are other signals that we can pull out from implicit things in the data. But I think one of the key powers that we have is we have a group of customer service agents. Internally, we call them COPs for customer operations, who are experts in our business. They know our business in and out. They know what different things mean. And so when there isn't enough customer-facing work for them to do, we can also give them different data labeling tasks to do. This example here is one that is up and coming for us, and it's improving our search model by getting our customer service agents to give us relevance ratings for search query help article pairs. So in this case, the customer had searched for move banks, and one of the help articles that we showed was about switching between the current and joint account, which I guess could be about moving between bank accounts, but maybe you could interpret this search query as about wanting to move their bank account to another bank. And so in this case, it's the kind of thing that's very difficult to infer by looking at interaction data, what articles are customers tapping on and things like that. But it's very easy to get from another human. So that's it. That's everything around the NLP. As you may have spotted in one of the earlier slides, I think now we have shipped probably about 20 NLP related models, and then the remaining are primarily in the fraud detection space. But now, as we move into new problem areas, a lot of these tools are not being limited to just NLP. They're being applied more widely to other problems across the bank. So the key thing being, can we maintain our speed and our productivity while being an incredibly small team and building more and more machine learning systems and getting them out the door quickly to validate them. So I'll leave it there. Thanks very much. Happy to take some questions. And I did promise the other data science managers that I would say that we are hiring as well. So do go check out our careers page.
Cool. So we have one question here from a friend in the US. And so he's quite interested to know how you relate the effectiveness of your models with actually solving the customer problem. Like, how do you imbue kind of business relevance and maybe business KPIs to your modeling teams?
Yeah, for NLP, there's some problems that are easier than others. So, for example, with the model that is for detecting what topic the customer is talking about, and we use that to route that to a specialized agent, then if that agent then picks up the chat and immediately sends it on to somewhere else, we get an immediate signal that the routing decision was incorrect. And that then links directly into a business metric of how much manual work are agents needing to do. So what is the overall handling time on these conversation tasks, which is something that can be quantified by looking at them getting tasks assigned to themselves and moving them on manually. For other areas, it's a little bit harder, search being that one whereby it's really hard to know whether a customer found what they were looking for versus abandoned, like just stopped looking altogether. There are some early efforts for specific areas. So if we see a customer search for card replacement and then go on to actually replace the card, then that can be considered a good signal, but that requires us to map out all of these problems deterministically, which is something that we don't want to do. Or at least it would narrow our focus to things we know rather than things we don't know. So for those, it's a little bit more difficult, but we look at metrics like contact rate and number of searches within the session, repeated searches, and these sort of things.
Cool. I think we have time for perhaps one more question, and then we'll try to keep the content on Cosmos. But we have Ravi and Otso asking a few questions. I'll just switch to Otso's because it's a little bit shorter, but Ravi, sorry, please join Cosmos and ask Neal your questions after. So Otso's question is, did you look at third-party solutions for the model store? And if yes, how did you decide to build your own? Otso being a regular London.AI guest and speaker. So going for that.
In terms of looking at third-party providers, I usually look at a few things. So first of all, is a third-party provider giving me something that they can do better than I can? So I guess I would trust a sentiment classifier that is being offered as an API, probably more than invest a month's time of someone on my team to work on doing sentiment detection. And then more specifically to things like the model store is how easily would it integrate with what we have? And that's something that, to be honest, spinning up a new microservice at Monzo has become quite an easy task. As you've seen, there's nearly 2,000 of them. So it was actually more effort to integrate with an external party than not. But the final point, I guess this is what comes up the most when I'm talking about build or buy, is whether the decision to buy means that I'm committing people on my team, when I'm committing their time to the integration and maintenance of that relationship with the third-party provider, as opposed to just making them more productive overall. So we have used some tools that come from other companies, Hugging Face, DBT, where the adoption of those tools was driven by the fact that everyone in the team started using them, and it made us more productive, and it didn't cost us in terms of maintenance. Or the costs in terms of maintenance were smaller than the productivity gains that we saw.
Got it. Well, thanks a lot.
Thank you.
Thanks a lot, Neal, for that chat. And again, if you have any questions, keep in mind right after Raza's talk, we'll be putting the link for Cosmos, and should be interesting. We'll have Neal. Neal can play something on the guitar if you want to challenge Aaro for free credits on or for free access to the platform. You can challenge him to a game of Pong. But without further ado, I want to introduce Raza from the Humanloop team. Plenty of things we could say about this company. It went through YC, London-based company that went through YC, and effectively helps you train and deploy your NLP models 10x faster with less labeled data, or with 10x less labeled data, not 10x faster. And yeah, we're giving the floor to him, and pretty excited to hear a little bit more to conclude this NLP focus chat.
And thanks so much, Alex. I'm really excited to be here, actually. I've been coming to these London.AI talks for a few years now, and I started off as a student, so it's kind of fun to go full circle, and I love this community, so it's great. It's great to kind
Thanks for that.
Be part talking. Oh, I think what you guys do is great. So I'm just going to share my screen, but can you guys see my slides?
Yeah.
Great. See, I'm actually really pleased to be going after Neal in some sense, because one way to think about what we're trying to do at Humanloop is build all of that infrastructure that goes around the ML models so that essentially other people can get the benefit of what Neal has built without having to rebuild and reinvent the wheel themselves. And so much of what you mentioned are things that we've been working on at Humanloop. So I'm really excited to kind of share that with you. I guess just a little bit of background on who we are. You know, Alex mentioned that we went through YC. So we're a spin out from the UCL AI Center, which is where I was doing my PhD when we started Humanloop. And then we did the first ever remote YC. So although we are a YC company, we did it from London. And you know, the team is mixed background of engineers and researchers. And we're kind of on a mission to make training NLP so easy that domain experts can automate tasks for themselves. So that's the kind of long-term goal. We kind of feel that, similar to what Neal said, that model training is increasingly becoming commoditized. And actually so much of the value lies in being able to get stuff out of the heads of subject matter experts and into models. So that's a little bit of background. And kind of what I want to talk about today is not just Humanloop, but kind of what I see as the kind of lay of the land in terms of ML deployment today and some of the problems we've seen and why we started building things in this way, how we're going about trying to fix them. So yeah, I guess what I see is the problem and also the opportunity. So, you mentioned Hugging Face. Everyone in this community is familiar with BERT, large pre-trained language models, ULM fit. Like, there's been huge progress in NLP in the last couple of years. That means that suddenly it's actually possible to build all sorts of applications. I mean, Aaro is a fantastic example of building on top of GPT-3. But my practical experience, having spoken to now like at least 100 data science teams, is that actually getting these things into production is still remarkably cumbersome and slow. And I kind of want to talk to you about why I think that is and how we might fix it. So the first thing that I want to talk about is the fact that I think the existing paradigm for how we build machine learning models is really linear and very, very waterfall. And so almost everyone we speak to goes on this journey. And I think Neal kind of hinted that he's seen people do it in the past. You have some idea for deploying some NLP or some machine learning model, someone collects the data, then you label the data, then you train models, you test them, and if the performance is good enough, they go into deployment. And increasingly nowadays, people monitor them as well. Although in the beginning, that was questionable. And there's different stakeholders involved at every step of this process. So early on, you have engagement from business leaders and other people who care about various stakeholders that care about the business outcome. When you come to do the annotation, especially for NLP, our experience has been this is quite hard to outsource. So for computer vision, anyone can put a bounding box around a pedestrian or a car. But in the NLP space, domain expertise and privacy mean that this is something that's often best done in-house. So even for something like customer service, your internal staff are your experts. But we've been seeing people build models for in the legal space, for medical chatbots, for contract understanding, where actually can have really quite expensive human employees of that company being co-opted into labeling tasks. And there's just a huge amount of opportunity lost by doing it in this very waterfall way. So oftentimes people will label lots of data before discovering the taxonomy is wrong, or they'll label the data and then they'll go and train things, discover the performance wasn't quite good enough. They need to go back and do things in a slightly different way. And post-deployment, your data drifts. So you deploy a model, and especially if it's interacting with anything customer related, it's kind of inevitable that you're going to need to get new labels at some point or update your data set in some way at some point. And if you're deploying in this way, that means going through this whole waterfall again from start to finish. And kind of one of the other things I just wanted to talk about is the fact that I come from a PhD background from academia. I've taught courses there. Like, training and testing is where all of academia lives, as far as I'm aware. And yet the quality of data set construction seems to be the thing that determines sort of the quality of these products in practice. And so that's where we're trying to focus a lot more. And getting enough data is still a problem for most companies who aren't Facebook. So I have this little graph here of Facebook published a paper a couple of years back where they managed to get improved performance by essentially using sort of distant supervision on billions of examples. But the reason I think that this graph is important or interesting is that the x-axis is logarithmic. And what you're actually seeing is that in order to get just linear improvement on their models, they actually need to get exponentially more data. And this is pretty much the norm in most machine learning, and especially NLP. And the reason is that most data sets in machine learning are long-tailed. And so actually, when you come to get production data, most of the inputs are things that are very uncommon. It's very easy to train models on the common data. But then when you come to deploy things, most of your inputs are coming from this long tail of rare instances, and getting high production performance is difficult. And I got a little quote down here from an Andreessen Horowitz blog on the economics of AI that basically points out that this is one of the reasons that AI companies tend to have worse margins than pure software companies, and they spend all of their time dealing with these long tails. So that's kind of a lot of background on basically why I think it takes ages to often get even simple classifiers trained and into production. And I'm conscious of time, so I'm going to jump ahead a little bit. But the question is then, okay, how can we do better? And what kind of tooling can we build that will make this easy for other companies to be able to do what Monzo's done and get lots of high production classifiers and other NLP models actually into useful products. And the core idea here is that we want to try and take that deployment waterfall and try and turn it into a closed loop process that is centered around the data. And that makes data annotation, processing, and the curation of data sets the main thing that you're doing, so that you get to high quality data fast, and actually abstracting away a little bit model training and deployment. And so the way we do this at Humanloop is at training time, we build a tool that uses active learning. And I'll explain a little bit about what that means in a second. And at test time, it means that on challenging data points, they get fed back to the labeling interface and they get handled by humans again. And there's really two things about machine learning software that make it fundamentally different from traditional software that our tooling is trying to address. And the first is that compared to traditional software, the quality of the data set you train on tends to have more impact on the output of the model than the code or the sort of architecture itself, right? So everyone can be using Hugging Face and Spacey. The thing that makes your model different is actually, did you have some specific data that was useful for your use case? And the other issue is that these systems are never going to be able to generalize 100%. So we need some way to be able to handle edge cases and to handle the situations when they fail, and to do that gracefully. Okay, so let me tell you a little bit about active learning and what that is and why we think that active learning basically will help with a lot of these problems. So the idea of active learning is that you couple the training of models with annotation in a single process. So instead of going down this linear route where you first label data and then train a model, you actually train the model frequently during the labeling process, and you use that model to query which data points should be labeled next. You can think about this a little bit like how you might teach a human to do something, right? You would never teach a human by just dumping a bunch of examples on them. You'd give them a small number of examples, you'd let them understand it reasonably, and then once they had a handle for it, you'd get them to sort of ask you questions where they were unsure. And that's the same principle behind active learning. And so if we would kind of just compare the traditional approach versus an active learning approach, traditionally you would collect all of the data, you'd label it, you'd train and evaluate, and then you'd deploy. And in the active learning world, you would first label a very small batch of examples. You'd rapidly retrain a model. You use that model to select which data points to label next, and then you repeat until the accuracy is good enough. And there's a few different advantages to doing this. And one of them is what I mentioned already, that most of the interesting data lives in this long tail. So by using the model to select the data you're working from, you can actually balance this problem during the labeling process and build data sets that have drawn more evenly from the whole distribution. And so that's one big advantage. You get to train models with less data. I'm just going to jump ahead to what they are. The other advantage is obviously getting faster feedback on performance. So actually during training, you're getting performance metrics, or during labeling, and so you can get a sense of how hard the task is and also how much data you need. And the kind of final one here that at the bottom is that because you've already hosted and deployed this model in order to sort of connect it to annotation interfaces, there isn't a separate deployment step. Actually, models can be continuously deployed. They can be improved through annotation. And as soon as you get better performance metrics on a test set, you can essentially update your model in real time. And the best companies in terms of advancement in AI are doing this already. So companies that are in the driverless car space where AI has to work, they've already built systems that do active learning. So Tesla and Waymo and Cruise, they have these systems already. In some sense, what we're trying to do at Humanloop is provide this in the NLP space to anybody. And I'm going to jump through the maths because I can see that I'm running low on time, but kind of how well might it work in practice? So I've just got a little bit of data here across a wide range of sort of use cases, comparing different active learning methods and showing that you can consistently get easily 50 to 70% reductions in the volume of labels. And that's not including the benefits from transfer learning or from other weak learning techniques. That's purely from the active learning alone. And the other thing that I would add is that active learning doesn't end at the end of training. So during training, we have this iterative fast feedback process. Models are being updated continuously. But post-training, low confidence predictions are automatically routed back to the labeling interface. So in a sense, you're actually sort of selecting the difficult examples at inference time and updating your models from them. And we can also monitor feature drift from the production data and route that back directly to the labeling interface. And this is something that we're doing at Humanloop. So just to kind of give you a flavor of what it looks like in action at Humanloop, you would have a team of annotators potentially labeling data This could be customer service data. In this case, it's some Reddit data. And as they're labeling, the model is being trailed in real time. You're getting performance feedback on the model. We're actively selecting the data points to be labeled next. So we're minimizing how much labeling you need. And because there's model already hosted, you can see predictions in the front end, but there's also an API to that model. So the same model that's being used to drive labeling can be easily deployed. And we also give you real-time performance feedback during that process as well. So that's kind of what we've built so far. And I just want to end the talk by talking about what some of the challenges are here and some of the exciting research opportunities, because we're a deeply research-oriented company. We're definitely hiring, and I wanted to give you guys a flavor of some of the things that we're thinking about. So firstly, for anyone who's thinking about using active learning themselves, you want to build a system like this to train your own models, there's a couple of things to be aware of. So the first is that active learning couples the data to the model being used. So because you're using a model to select what data to annotate, there is actually now some bias introduced by this process. You've kind of made the data that you've trained particularly good for the model you used. And this may or may not be an issue in practice. And our experience has been that for like academic data sets, this is a big problem. But for most industrial data sets, the lifetime of the data is probably shorter than the lifetime of the model, in the sense that the data needs to be frequently replenished to keep it up to date. And you're not actually going to build a data set and hold it for years and years to train a model in the future. You know, your customer data changes faster than this matters. You have to be careful about the active learning method you use. I skipped over a bunch of maths in the interest of time, but to make active learning work robustly and well means being able to calculate good uncertainty measures from deep learning models. And that's actually quite a hard research challenge. And then finally, active learning requires frequent retraining of models during labeling. And there's a few ways people get around this in practice. One is to train models online. So instead of doing a full retrain after every batch, you can sort of do online retraining. Another option is to be updating subsets of the parameters that you think affect the model the most. And then what you can do is infrequently retrain the whole model. And some research questions that we've been thinking about recently is test set creation. So it's very common for companies to be using active learning for training, but actually one of the biggest sort of labeling headaches is actually evaluating models. If you have large class imbalance, building big enough test sets to get a reasonable estimate of how a model is actually going to perform in practice can be very expensive. And we've also been thinking about how to aggregate multiple annotations from different annotation sources in intelligent ways. And those are all, I think, really quite hard, but interesting research challenges. So just going to kind of finish on the point of telling people that we're hiring and asking you to join us. And leave you with this tweet from Andre Kaparthi where he says, "I'm sorry, he thinks gradient descent can write better code than you." To a certain extent at Humanloop, we're in agreement. We think you should focus on curating your data set and let gradient descent and ML do the rest.
Perfect. Well, thanks a lot for that presentation. It's always great to have someone go from London.AI guest to speaker. If you have any questions, pop them through the comment section and we'll ask them. I think the first one for you, Raza, is obviously having taken a look at your background, Jordan and Peter's, it's quite interesting just to see the active learning component, but wanted to understand why the focus on NLP. Do you think an active learning solution right now, the best use case you could have applied it for is NLP? We're seeing quite a few companies like V7 and others go after machine vision, not necessarily with active learning. Just curious as to what made you and the team choose NLP as the focus.
Yeah, it's a great question. I mean, one is a general excitement about the rate of improvement in NLP over the last couple of years. So, people have talked about NLP's ImageNet moment, the fact that actually, for the first time, it's become easy to do large-scale transfer learning, and things like BERT and other transformers models have made it easier than ever before. So more and more companies are considering NLP than they would have been in the past, and the tooling isn't really there yet. And then the other reason is that, we view this as kind of a new software paradigm, right? It's a way of teaching computers in order to achieve your goals. So instead of programming by writing, iterative instructions, you program by giving examples, curating a data set, showing what you want the computer to do. And what we're really excited about is the ability to use that to automate high-end knowledge work. So things that today is being done by lawyers or doctors, or even white collar knowledge work like customer service automation. And most of that data in the enterprise is text data, and it's about language understanding and understanding how humans react to each other. And so what we really want to build is something eventually a little bit like an AI coworker, right? A system you can interact with, provide examples to, teach, and have it learn from you and automate your work.
And we have one question from Miguel Martinez from Signal, who is also a speaker.
Hi, Miguel.
And his question is, do you have any special approach to predict the quality of your models once they are applied with the full real data, given that the AL changes the distribution between training and real data?
Yes, we do. And this is actually something that has been like an active area of research for us recently. So there's one thing you could do, which would just be like collect test data separately to the active learning data. So build a large random test set. And although your training set may be collected under active learning, your test set would still be valid for evaluation. That's not the approach we take. And the reason why it's not the approach we take is when you have really large class imbalance, it's hard to build appropriately sized test sets. So imagine I have a class that shows up 1 in 100 times. Just to see 10 instances of that, I need to label 1,000 data points if I'm labeling at random. And you need many more than 10 data points to have a reasonable test set. And so what we're actually doing is we are using a sampling distribution from the model to select test data, and then making adjustments to that using importance sampling to give you estimated performance metrics that as you would have got them from an unbiased or a randomly selected test set. And the other thing that we're doing a little bit differently to anything I've seen on the market is we provide error bars on test metrics. So many people are used to reporting test metrics as a point estimate. My test set F1 is some number. But in reality, because you have a finite test set, you have uncertainty about what your test metric is. And you should know how much that is so that you know how much test data you need before you can actually believe that. And we can give you those error bars.
Sounds good. Well, thanks, Raza, for a fantastic presentation. And I'm about to post the Cosmos link, so we'll get our speakers and our guests joining, and you can bombard them with whatever questions you didn't get now. But before I lose everyone, we do these events for free, but we kindly ask you to make a donation if you found it interesting. And Nathan will give a few words on what that money goes towards.
Yep. So you can go to raise.co/donate. And what we're trying to do here is create a Humanloop style recursive loop of cool speakers talking about best practices, inspiring new generations to follow similar footsteps, but also engage with open source. And so we use the funds to give fellowships to folks who are developing open source projects that many of us can be using. So in particular, we funded quite a few grants through OpenMind, doing privacy preserving machine learning, but also to solve problems in climate change with Open Climate Fix. And so if those are causes you care about and you'd love to support the community, then please go ahead to rise.co/donate.
Great. Well, thanks a lot for that, Nathan. And Nathan and I will be going around the room and pestering people to take a look at the website. I'm posting the link to Cosmos now in the comments. Half the fun is discovering how it works, but we'll be around if you have any questions. And yeah, feel free to stick around, ask your favorite speaker some questions. And before we go, a special thank you to our 3 amazing speakers for a fantastic NLP focused evening, and see you in the metaverse through Cosmos.